We can welcome Professor Probal Chaudhuri for the talk, for the tutorial actually. He's going to give you. Probal, are you there?
Yeah, I'm here, and I'm sorry for being late in the morning.
Okay, no problem. Yeah, please carry on. Okay, I'll switch off my mic. Thank you.
Okay. So the participants, do you have any question? Because I have prepared some problems, but before we start discussing that, let's hear from you if you have any questions. And I have requested the organizers to give my slides to all the students. There were one or two people who separately requested me. I have sent it to them, but I have requested that it be distributed among all participants. Okay. So anybody has any question about what I discussed yesterday? If you have any question, please say so. Can you hear me clearly? Hello?
Yes, sir. Yes, sir.
Okay. So
yes, sir.
Okay, so anybody has any question? Okay, if not, then I will start with the problems that I have prepared for you. Okay, so can you see my screen clearly?
Yes, sir.
Okay, so this will take
Yes,
you
sir.
probably a few minutes. So let's try to understand what this problem is about. Okay, it's a very simple linear regression problem, and there is no intercept term. Okay, so yi is beta times 1 by I to the power alpha. Remember yesterday I was repeatedly telling that these xi's may be fixed or random, but we always treat them as fixed. Now here these xi's are actually fixed. So xi is 1 by I to the power alpha, and alpha is positive. And this yi satisfy this distribution. My question is that if you calculate the least square estimate, first of all, what will be the least square estimate? Can somebody tell me what will be the least square estimate? Take a piece of paper and pen and do a little calculation. What is the least square estimate? Remember, there is no intercept term. So xi is 1 by I to the power alpha. So it's like a regression model yi equal to beta xi plus epsilon I. Yes. Somebody wanted to say something?
Sir, summation yi by I to the power alpha divided by summation yi square into summation of 1 by I to the power 2 alpha.
No. From where? How? Why in the denominator you are getting y square? I'm asking for
Why
yi square in the denominator? Check your calculation carefully.
Sir, summation yi into summation I to the power alpha.
Product of two sums in the numerator.
Yes, sir.
No. That's not correct. Why don't you write it down as beta times xi and solve the least square problem and see what you get? So I got two responses. Neither of them is correct. But
sir?
Yes.
Sir, it is summation yi I to the power minus alpha by summation I to the power minus 2 alpha.
Yes, that's correct. Okay. So can you repeat it again so that everybody can hear you?
It is summation yi I to the power minus alpha by summation I to the power minus 2 alpha.
Right. Okay. Now comes the actual question. For what value of alpha the least square estimate of beta is consistent? Now, all of you work on this problem. I give you 5 to 10 minutes time. So what do you have to do here? You know that the least square estimate is unbiased. You only have to check what?
So variance tends to 0.
Right. See, I mean, yesterday we were talking about consistency in a much more general setup. Okay, we are talking about eigenvalue of the matrix X transpose X inverse or X transpose X. Here, the X is just a scalar constant. So X transpose X matrix is really a scalar, and that condition about eigenvalue really boils down to that condition that whether the variance goes to 0 or not. Okay, so you check and tell me for what value of alpha the variance will go to 0. And if variance does not go to 0, is it not consistent? I mean, that's another question. Anyone got the expression for the variance of beta hat?
Yes, sir.
Yeah.
Sir, sigma square into diagonal matrix. The diagonal matrix will contain 1 to the power
There is no
alpha.
matrix here, right? I mean, there's just a scalar.
Yes,
I
sir.
made the problem simple enough for you. So why do you bring in matrix? So what's the variance of beta hat?
Sir,
You have the expression for beta hat already. It's a linear
sigma.
function of the yi's.
Yes, sir.
Hello, sir.
Yes.
So the expression is sigma squared by summation I to the power minus 2 alpha.
Okay. So somebody said it is sigma squared divided by summation I to the power minus 2 alpha. Now let's see if everybody is getting that or not. That's the first step.
I got this.
Sorry, sir, it's one. No, it's okay, sir.
It's good.
Yes, sir. It is.
Okay, good. Now you tell me. Now it's a problem in calculus. For what value of alpha this will go to 0? So in order for this to go to 0, what should happen to summation I to the power minus 2 alpha? That should go to what? Summation I to the power minus 2 alpha
That
should,
it should go to
Diverge.
infinity.
it should
Yeah, it has to
diverge or go to
diverge.
infinity, right?
Yes.
So what should be the value of alpha?
Alpha should be
Alpha
less than
should be
1.
negative.
Sir,
No, alpha is
Alpha-
positive.
sir, 2 alpha should be
Yes,
Sir,
2
alpha
alpha
should
should
be
be
less than
half.
1.
2
Alpha less
alpha
than
should be greater
Greater
than
than
1.
half.
greater than
Alpha
half.
greater than half.
Alpha less than half.
Alpha
Less than
Alpha
minus
less
half.
than
Okay,
Alpha
now I'm
less
getting
than
it. Too many answers. Okay. Okay, now first of all, somebody said alpha less than half. Do you mean alpha less than half or less than equal to half? Because what
less than
happens at half?
equal to.
Alpha less than equal to half.
equal to.
Sir,
Yes.
sir, it is T series. That's why it will convergent if alpha is greater than half, I think.
Okay. And if it converges, then the estimate will not be consistent. That's what you are saying, right? It has to diverge for the
Yes,
estimate to
sir.
be consistent. Okay. So alpha less than equal to half makes summation I to the power 2 alpha divergent. I agree with that. Okay. Now that means if alpha is smaller than or equal to half, the estimate is consistent. But what makes you say that if alpha is bigger than half, the estimate is not consistent? Because the condition that I gave you last time, that's only a sufficient condition. Do you understand what I am trying to say?
Yes, sir.
Yes, sir.
So the condition that I gave you yesterday is only a sufficient condition for consistency. Now, if that condition does not hold, it may still be consistent. Now you have to resolve that issue. So let me tell you the correct answer. You are right. Indeed, only for alpha less than equal to half, it will be consistent. And for alpha greater than half, it is not going to be consistent. But can you tell me why for alpha greater than half, it's not going to be consistent? What happens for alpha greater than half? Summation I to the power minus 2 alpha is a convergent series in that case. And so that has some value. Let's say summation I to the power minus 2 alpha, when alpha is bigger than half, converges to some constant C alpha. It depends on alpha, so I call it C alpha. So what will happen to the variance of beta hat? It will converge to sigma square by C alpha. Is that correct?
Yes, sir.
Yes, sir.
So, and that is a positive variance. So essentially then when n tends to infinity, it will be something like a quantity that is normally distributed with mean beta, because it's a beta hat is an unbiased estimate. So the mean is always beta. So it will be normally distributed with mean beta, and for large n, it will have variance sigma square by C alpha. So if it is a variable like that, how can it converge to a constant? It cannot converge to a constant. Do you get my point?
Yes, sir.
Okay, so it is consistent if and only if alpha is less than equal to half. Alpha less than equal to half is sufficient for consistency. That is easy from our previous discussion and also from direct calculation. But lack of consistency or non-consistency for alpha greater than half requires little argument, not much. Okay. So anybody has any question about this problem? Do you all understand the solution? It's a very simple problem. I wanted to start with a very simple problem so that it helps you to refresh the things that we have discussed yesterday and also sort of get a little more insight onto the issues. Anybody has any question? Okay, if nobody has any
Hello,
question,
sir.
yes.
So can you
Sir,
repeat this reason that you had given
I
for
say it
alpha
again.
greater than half?
Okay, if alpha is greater than half, then summation I to the power minus 2 alpha converges to something. So let's call that let's call that thing to which summation I to the power minus 2 alpha converges to C alpha. So that means as n tends to infinity, the variance of beta hat will converge to sigma square by C alpha. Are you okay with this? Are you okay with this?
Yes, sir.
Okay. Now we know that beta hat is an unbiased estimate and its variance is sigma square by summation I to the power minus 2 alpha. So as n tends to infinity, its distribution will go to what? Its distribution will go to normal beta and sigma square by C alpha. Then how can then beta hat converge to beta? Because if beta hat has to converge to beta in probability, then beta hat has to go to degenerate beta. It can't go to a normal distribution with variance sigma square by C alpha.
Sir, I understand.
Okay. Now this will require some calculation, and I want you to do calculation for at least the first problem. Maybe the second problem will take more time, but you'll have to tell me the idea and then you can finish it later. Okay. So here is the data. Okay. 10 minutes time. I want you to fit two lines to this data. First, I consider a line without any intercept. So y equal to beta 1x, like the previous problem. And then I want to consider a line with an intercept on beta 1. And in both the cases, these are two separate problems, 1 and 2. I want you to fit using the method of least absolute deviation. So first you do one where you are fitting y equal to beta 1x. And you have to tell me what is the answer. That you should not take more than 5-6 minutes, because I have discussed this in great detail yesterday. So as you do your calculation, can somebody tell me what are the things that you have to calculate here for the first problem, y equal to, when you are fitting y equal to beta 1?
So we have
Sir,
to
Yes?
estimate beta 1 hat.
Yeah. So what do you have to calculate?
So we need to estimate beta. We can estimate beta 1 hat by implying the formula summation yi xi minus summation y.
No, that's for least square.
Yes, sir.
But read the problem carefully. What is there at the end? To the data by?
Oh, I see. So I have to use the
You have to
absolute
use
value.
what Laplace did last time. This is not least square problem. Least square problem was the previous one.
Sir, I am doing. I am dividing each yi by xi and taking.
Yes, that's the first step. You have to divide each yi by xi. And then
taking the mod xi as the weight.
So mod xi in this case, they take integer values. To make your life simple, I have made them all integers. So mod xi takes values 2, 3, 4, 5, and 1. They are like frequencies now. So you have to order the zi values. Zi is what? Yi by xi. So you have to order the zi values in that weight distribution. Okay, do it and tell me what is it.
Okay, sir.
So what is the median in the weight distribution?
Sir, y4 by x4 is the median of beta.
Not median of beta, median of the zi's or the ratios.
Yes, sir.
Can you explain why?
Sir, I am taking the modulus values and order them and taking the weight of them.
Well, I mean, there's no issue of modulus values here. Everything is positive. Okay? So we don't have to worry about modulus anymore.
Yes, sir. Sir, I am taking the values and ordering them.
Okay.
And
so the first value, I think if I calculate y1 by x1, I'll get 2.1. And the frequency for that will be 2. And then here, if I take the ratio, it will be 1.7 and the frequency for that will be 3. And here it will be 5.7 divided by 4. So that will be like 1.4 something. And then 5 and this is even, so this is going to be how much? So 1.46 like that. And this is going to be 2.9. Okay, and the frequency for that is 1, whereas frequency for this is 5. So, what is the median of the ratios in the weight distribution? Not the usual median, the weight distribution. You have to take the frequencies into account, or the weights into account.
Sir, the 7th observation is the midmost value. So I am finding that the 4th observation.
Is it the 7th or 8th? Because there are 15 if I add up the weights. Right?
Yes, sir.
Plus 3, 5, 4, 9, 5, 14 plus 1. So 8th is the middlemost.
Yes, sir. Sorry, sir. I have calculated.
So what is beta 1 hat?
Sir, this is y4 by x4.
Okay, so you said it is y4 by x4. Is that correct? Let's hear from others. So somebody said the least absolute deviation estimate of beta 1 in first problem, that is 1, when there is no intercept term, is y4 by x4. Is that correct?
Yes, sir.
Everybody thinks so? Now, I have not done the calculation myself, so you have to assure me that that is what you are getting. So remember that after you calculate the ratios, you have to order them according to their values. And when you order, certain values will be repeated according to the weights. So, and the weights here are 2, 3, 4, 5, and 1. So altogether, the total weight is going to be 15. So you order them in that weight or in that frequency and calculate the 8th observation. Now, when you come to the second problem, what do you have to do? What have you learned about the second problem? That was Gauss's solution. What was the solution?
Sir, by taking the same procedure, by dividing it by xi and taking
Will
the.
that work when there is an intercept term?
Sir,
Remember, I said that Laplace solved this problem without intercept term. Then Laplace assumed that it passes through average of x and average of y, that point. But that is not correct because least absolute deviation line may not pass through it. So it was not right solution that Laplace gave. And I stopped there. And then we went on. We discussed about this square. And then where did I reach? I gave you the solution of Gauss. And that was what? What was the solution that Gauss gave for this problem?
Finding out the optimal line.
Yes.
The
So
optimal line.
how many elemental lines are here?
5.
Only 5. How do you define an elemental line? You take a pair of points
Then
and join them.
5 choose 2,
Sir,
10.
5C2.
So that is how many?
10.
Yes. See here the size of the data or the size of the sample is same as Boscovich's data, right? 5. So there are 10 elemental lines like Boscovich had. And you have to find which one of them gives you the smallest absolute value of the residuals. Sum of the smallest value for the sum of the absolute values of the residual. So you have to calculate it for all 10 lines separately. So that will take you a lot of time. Okay. Well, let's not do it now. You can do it yourself. But do you all understand the procedure? Here, for the first problem, the solution is quick. You just have to calculate the ratio of y and x, and then all those ratios z, and you take these z values and order them. But when you order them, some z values you repeat according to the weight. Here the weights are 2, 3, 4, 5, 1. And as you repeat them altogether, you have 15 observations. Because of the weight, you have repeated some observations. Okay. So then you look at the 8th observation. So for the first problem, there is a very clear solution, and you can calculate it quickly. But for the second problem, when there is an intercept term, you have to find out the elemental line that gives you the best result. And so you have to calculate how much is the sum of absolute deviation for different elemental lines. So there are 10 elemental lines, and you have to calculate the sum of absolute deviations for all of them and pick up the one that gives you the smallest. Now it can very well happen there are more than one elemental line that gives you optimal, then both are LAD solution. So that's one important thing about LAD. Okay. See, least square estimate under some condition is unique, but LAD many times it may not be unique because there may be more than one elemental line that gives you the same value for the sum of absolute residuals. So there is an issue of non-uniqueness here. So there are a lot of computational issues with LAD. That's why least square remains still very popular. Anybody has any question about this second problem? Anyone wants me to discuss anything further about the second problem?
Sir, the solution you have discussed yesterday, can you please repeat that?
So what
About
was the
second.
solution you were talking about? Number 1 or number 2?
Sir, number 2.
Number 2. Now somebody actually responded and then I took up from there. So can somebody explain how to solve number 2? So number 2 is here. Y equal to beta naught plus beta 1x. Can somebody, I have said it once, I want to see whether anybody can repeat it for me. What did I say last time? What was Gauss's solution to the problem?
Sir, finding out the optimal line.
Yes,
all
finding out the optimal line. Optimal among which lines?
elemental lines.
Yes.
The
And how many elemental lines are here?
5C2 means here 10.
10. So take any pair of points and you can calculate the equation of the line. So you'll get a beta naught and a beta 1. That may not be the right beta naught or beta 1. So take a pair of points, calculate your beta naught and beta 1. And then for each such line, you calculate sum of absolute deviation. Do you get my point? So
Yes,
you have to calculate the sum of absolute deviations for each of those 10 elemental lines. And then find out for which elemental line you are getting the smallest value for the sum of absolute deviation. Now, whenever you have an elemental line, there will be some deviation. So suppose I take the elemental line that passes through these first 2 points. Now, because the line passes through these first 2 points, then for that elemental line, there will be no deviation from the first point and the second point, because they are right on the line. So there the deviations are 0. But for remaining 3 points, there will be some deviation, and deviation is always calculated in the y direction. So you essentially take the equation of the line that passes through these 2 points, and then you check how much is the deviation in the y direction for these 3 points. So essentially, using the equation, you calculate the value of y and compare it with y3 and look at the difference. And then you add up those things. And as you add them up, you get a value for the sum of absolute deviation. So that's the deviation that you get for the elemental line passing through the first point and the second point. And you do it for each and every elemental line. And then pick up the one that gives you the smallest value. And it may happen that there may be more than one elemental line that gives you the smallest value. Okay. So let's move on to the third problem. Again, here you have to think a little and then formulate the problem and tell me how you solve it. Here I am not giving you any values, so there is no numerical computation involved, but you have to tell me the procedure. So I give you 5 to 10 minutes time, think about it and give me the procedure. So when I write this yi vertical line xi, I mean yi given xi. So people call that, so yesterday we talked about logistic regression model. People call this Poisson regression model or log linear regression model. It's called log linear because if you take the log of the mean, then it is a linear function of x.
Sir, if I write the model as yi equal to e to the power beta naught plus beta I xi plus error I, then
Will it be possible to write like that? You can write like that, but then epsilon I will have some strange distribution because yi's have a Poisson distribution.
Yes, sir.
Now, is this fact that yi's have a Poisson distribution is of any help? Yesterday, when we were towards the end, we discussed something. What is it that we were discussing towards the end?
Sir, logistic regression.
Yes, and what was the estimation procedure we used there?
Sir, iteration method.
No. Basic estimation procedure. Logistic regression, before that, even least square also we discussed again.
Likelihood
What was
estimation.
maximum likelihood estimation? So can it be of any help? That's the hint. Now you do it and tell me how will you do it.
Sir,
Yes.
and sir, if I write my model as yi equals to e to the power beta naught plus beta 1 xi plus epsilon, when I am taking a multiplicative error term and then I take log, then I will fit.
No. See, why are you trying to bring up an epsilon I here? That's unnecessary. Remember when we did the logistic regression model, we did not bring up epsilon I. We just wrote down the likelihood.
Oh,
Can we
yeah.
not write down the likelihood here based on this conditional distribution? So this is something you need to keep in mind. When we write the usual linear regression model and such things, we have this plus epsilon terms repeatedly. Now you have to get rid of that from your mind when you are talking about some other types of regression model, like the Poisson regression model that we have here, or the logistic regression model.
Okay.
Try to just write down the likelihood. For example,
Okay.
if I observe yi Poisson with, so this is like the lambda for the Poisson, right? I said Poisson with mean e to the power beta naught plus beta 1 xi. So this e to the power beta naught plus beta 1 xi is like lambda.
Okay, sir. Okay, sir.
Sir?
Oh.
Hello, sir.
Yes, I'm hearing you.
Can I say the likelihood function?
Yes, please.
Sir, if I take it as lambda I, means the mean, then it would be the product of e to the power minus lambda I to the power yi into
Divided by?
yi factorial.
Very good. And then you substitute the expression for lambda I there. Then beta naught and beta 1 will be coming up there, right?
Yes, sir.
And then that is the thing that you have to maximize. But you see, it's a very complex expression. But when you solve it by numerical method, well, all this complex expression do not matter. You just run a computer program to do the iterative computation and it comes up. So you see that maximum likelihood estimation, I discussed it for logistic regression, but it can be used for many other problems. Here, there is no logistic regression sitting here. It's a Poisson regression problem. Do you all understand the problem? Anybody? So here, that's all I wanted to hear from you, the procedure. You have to write down the likelihood and maximize the likelihood. Of course, when you try to maximize the likelihood, you'll be taking log and differentiate that with respect to beta 1 and beta naught and set that equal to 0. So you'll get two equations in two unknowns, but those will be nonlinear equations. And so you solve them using Newton's method, Newton-Raphson method. Anyone wants to ask any question about the third problem? Okay. Now, the fourth problem is actually written in a slightly vague way, but let me see how you react to it. Okay. So we have a data set where it so turns out that variance of x and variance of y is same. That can happen. I am asking you, what will you be able to say about the two least squares regression lines?
So they will have the same slope.
Is that correct? Okay, now, did I not tell you something that the two regression lines, so one regression line is like y on x, and the other is x on y. So it's like you interchange the role of x and y, and you get two regression lines or two least square lines. But I told you something about these two regression lines, that in general, always the two regression lines pass through a common point. What was that common point?
So x bar
y
y
bar
bar.
comma
X bar, y
x
bar.
bar.
So if they have same slope and they all pass through, both pass through a common point, then the regression lines will be same. Is that correct?
Yes, sir.
Yes, sir.
Yes, sir.
Think about it carefully. Why don't you write down the two regression equations and look at them carefully? See, when you use the term slope, you always write it as y equal to mx plus c, and then m is the slope. Now, if you interchange the role of x and y, the slope should not be interchanged like that. Okay, you have to keep that
So the
in mind.
slope is same, but
Sir,
with respect to
Sir,
x
I
and
think,
y.
sir, intercept will negative of one another.
No, no, no. I think the answer is much more simple.
sir, the slopes
Okay,
will be
let's hear.
reciprocal of one another.
Yes, the slope of
Perpendicular.
one is the reciprocal of the other. That is correct. See, when you write down the regression equation, when you are doing it like y equal to beta naught plus beta 1x, then beta 1 becomes correlation times the standard deviation of one divided by the standard deviation of the other, because the ratio of the two standard deviation is 1 is going to be the correlation. But then if you take the other regression equation, that is like x equal to some gamma naught plus gamma 1 y, then gamma 1 will be again rho. But if you take gamma 1 on the other side, then it becomes 1 by gamma 1, and then it becomes 1 by u. So now, but what is the geometric interpretation or implication of that? If one has slope reciprocal of the other, the two regression lines must pass through a common point. That is true always. But if one has slope reciprocal of the other, geometrically, what does it mean?
Sir,
perpendicular.
Perpendicular point.
Perpendicular, is
Two are
that correct?
perpendicular to each other.
Are they perpendicular? What is the condition for perpendicularity? Product of the
So,
slope
sir,
should be
perpendicular m1 mt equals to minus 1.
minus 1. Here it is not minus 1. Here it is plus 1. Let's assume that the correlations are positive. So if the product is plus 1, what is the implication?
So they are parallel to each other.
How can they be parallel? Parallel means that the slopes must be same.
Yes, sorry, sir.
Can somebody precisely describe the geometric implication of one slope being just the reciprocal of the other? Why don't you draw a picture and try to answer by look at the picture and try to formulate your answer in terms of the picture?
So the angles
Sir.
of both the lines are same, but one angle is measured about x-axis and other is measured about the
Right.
y-axis.
So one angle is with the x-axis and the other angle is with the y-axis. So it is like, I mean, the angle gets shifted by 90 degrees, something like that. Okay. So if one angle is theta, other angle is 90 degree minus theta. So that's how the two regression lines will look like. They are not going to have same slope. They are not parallel. They are intersecting at a point, but there is an angle between them, and the angle can be described nicely like that. So it's like one line, if it makes angle theta with the x-axis, the other line will make angle 90 degree minus theta with the x-axis, when theta is smaller than 90. Good. Anybody wants to ask any question about fourth problem? Any more question from anybody on the fourth problem? Okay. If not, let me move to the last question that I have brought today. This is actually an easy question, and you have to give me the answer. So we have a quadratic regression model that Y satisfies. and y and x has set two random variables in this case. Okay, and x has a symmetric distribution now. And I am also assuming epsilon and x are independent. What is the correlation between x and y?
Sir, 0.
Why do you say 0?
Sir, because it's quadratic relation and no linear relationship between y and
Is
x.
it always true that if you have a do you mean to say that your answer is 0 irrespective of this condition that I have given you, that x has a symmetric distribution around 0? It's not true. Suppose x takes only positive values, okay, and y equal to something like x squared. Suppose y is approximately equal to x squared. So then as x increases, y will also increase, and then the correlation is not going to be 0. There is no linear relationship, but there will be positive correlation. You have to do some calculation here, and you have to use that condition about symmetric distribution of y. A symmetric distribution of x.
Sir, 0.
Why 0?
Sir, we can write expected covariance equals to expected
I.
value of x, y
I.
minus expected value.
Me
The
आगे
expectation
लगता
of x
है.
will be 0. Then
okay, maybe one person, Pranay Krishna. Okay.
Yes, sir.
Okay, so carry on.
Sir, we can say expectation of x equals to 0 by symmetry. And,
yes, very good.
Sir, in the covariance term, we will only get expectation of x into y, and then we can write y as beta naught plus epsilon.
Yes, right.
And
right.
Again, we will get x1.
Essentially, if you calculate expectation of xy, you will get expectation of beta naught times x, expectation of beta 1
Beta
times
1 x square.
x square times x, so that will be beta 1 x cube. And then expectation of epsilon times x, and epsilon and x are independent, so that is going to be expectation
0.
of epsilon times expectation of x, so that will be 0. Okay, so expectation of xy is 0, expectation of x is 0, so the covariance is 0, so the correlation is 0. So you see, I only said x has symmetric distribution, and there are lots of choices for x. So for all those distributions, for any distribution of the error term epsilon, we are going to have correlation 0, though there is a very nice relationship here. And that is not because that it is a quadratic relationship. In fact, instead of beta naught, if I have something like beta naught x square plus beta 1 x to the power 4, the same thing will happen. Because any odd power of x will have expectation 0 because of this symmetry. So do you all understand why the correlation is 0 in this case?
Yes, sir.
Okay, so this is an example that 0 correlation, but there is a relationship between y and x. There are many such examples that you probably have learned from your class, and here is one example. And this example is nice in the sense that you can sort of modify this example in many ways, and then you can get lots of examples where this will happen, that the correlation is 0, but there is a nice polynomial relationship between y and x. And the residual may have any distribution. It doesn't matter so long as it is independent of x. Now that's the problem that I have listed, and I have not brought any other problem. So if you have any question, I will just discuss that or try to answer that. Otherwise, I have nothing more to say today.
Sir, in the question number 3, whenever I am writing the, yes sir, in the Poisson model, whenever I am writing the likelihood, I am taking as likelihood of yi given xi and y1 given x2.
Yes. Every time you write down the likelihood using the conditional distribution of y given x. And the conditional distribution of y given xi is like Poisson with parameter lambda I, and lambda I is this expression.
Sir, after doing that, I will take the log likelihood and then take the derivative of the...
Yes, and that will be a very complicated expression. You will not be able to solve it manually. and you will not get a nice expression for the maximum likelihood estimate either.
Okay, sir.
So you will be solving it numerically.
Okay, sir.
Anybody has any other question? So anybody wants to ask any other question? Okay, if not, then Gopalda, I don't think I have anything more to discuss. So,
Sir, I have to ask one thing, sir.
yeah, sure, carry on. I was just waiting. Yes.
Sir, we have seen many examples where the relationship between y and x is quadratic, but correlation comes out to be perfectly positive, sir. Then how to interpret that thing, sir? Because
See, the
relationship is quadratic,
correlation
not.
measures the strength of linear relationship, but it is actually a mathematical fact that if you have an increasing relationship between y and x, then the correlation will always be positive. You can prove that if y is an increasing function of x, then the correlation between y and x will be positive. So the quadratic expression, you see, when something increases like a quadratic, it's like there if you do a straight line fit, that will not be a perfect fit, but it will reduce the variation on y to some extent. So it's like residual sum of square will be smaller than the total variation. It will not reduce it absolutely. So if there is a perfect linear relationship, then the residual sum of square after you fit a straight line is going to be 0. That's not going to happen when you have a quadratic relationship. Okay? But the residual sum of square will be smaller than the original variation in y. That's why you are getting a positive correlation. So the linear relationship captures the relationship to some extent, but not perfectly. That's how you can explain it. So if you have y equal to x square, that curve is somewhat approximated by a straight line. Do you get my answer?
Yes, sir. Sir, will you please repeat the last statement?
So it's like, suppose I have y equal to approximately x square, and x is from 0 to 5 or something like that. So then it will be like it will be just one branch of the parabola. Okay. Now,
Yes.
if you look at one branch of the parabola, you can approximate it by a straight line to some extent, isn't it?
Yes, sir.
So that is why you are getting some positive correlation.
Okay, sir.
In fact, as I said, this is a mathematical fact that if y is an increasing function of x, suppose you have two variables, y and x, and y is an increasing function of x, two random variables, then correlation between y and x will be always positive. That's a mathematical fact.
Sir,
It doesn't have to be a linear function.
Sir, if we have to explain it in somewhat layman language, then how will we explain it?
I don't know a simpler way to do it than just drawing that picture. If you have a quadratic, you draw the picture, that will be like the branch of a parabola. And then you say when you are fitting a straight line, then you are approximating that branch of a parabola by that straight line, which sort of approximate that curve by that straight line. Okay. And then the residual sum of square that you get is the residual sum of square that is coming out of that straight line. See, think of correlation in terms of the residual sum of square that I have given you in the slide yesterday. Remember, I gave you r square equal to 1 minus residual sum of square divided by total variation in y.
Yes, sir.
Okay, so if the linear relationship is good, then the residual sum of square will be very small. But when the linear relationship is not very good but reasonable, like what happens when there is a quadratic relationship, then the residual sum of square will still reduce the total variation to some extent. So we'll get some positive value for r.
Okay, sir. Thank you.
I mean, it's a bit technical because I think this concept of correlation itself is technical. Okay, so you can't explain it to somebody who does not understand how correlation is defined or formulated. Okay, anyone has any other question? Okay, Gopalda, so.
Thank you, Probal. It has been very nice. Students, please thank him for all the lectures and tutorials, and unmute your microphone and give him
Thank
the.
you, sir.
Thank you, sir.
Thank you, sir.
Okay, sir,
Thank you,
before you
sir.
start,
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.